Alright, this is the first video of your Biochem unit. I'm thinking we'll have around 4 videos, so hopefully they'll all be pretty short, but this is the first basic intro. So our unit topics. This video is on periodic table, atoms, elements, and compounds. So there will be a video on each of the other 3 things later. Alright, so first of all, what is chemistry? So I'm sure you all have heard the term chemistry. In fact, many of you will be in chemistry next year. But it's basically just the study of matter. And how does it relate to biology? Well, specifically in the organic chemistry side, which is the study of carbon. And we'll learn about macromolecules probably the 4th video, and those are things that are important for all living things to survive. Alright, so like I just said, chemistry is the study of matter. Atoms, then, are the building blocks of matter. So the nucleus of an atom contains protons and neutrons. So the charge of protons, think P, positive, they're positively charged. The charge of neutrons is neutral, so it's just a 0. And then electrons are outside of the nucleus, and these are negative. So this is inside, both of those combined, and then electrons are outside. So what is in the nucleus of an atom? So we just said it's protons and neutrons, and we'll just use their symbols. And then the electrons they fill shells. They're called the outer shells. So they fill shells around nucleus. Oops, we ran out of room. Should get it. So an atom, what does it look like? We're going to go to the next slide. So hopefully you've seen something like this before. So your nucleus is right here. So all of the green are your protons, and you see they're all in the middle. And all of the red are your neutrons, which are also in the middle. And then your electrons fill these shells. So these are your outer shells. And there's more and more bigger elements have more shells. So this is going to be a relatively small element, which we'll learn how to tell size in just a minute. So elements then are composed of atoms. So element is many atoms of the same that make up an element. And then each atom has its own unique name and symbol. So something like helium. That's its name. Its symbol is He. Carbon. Its symbol is C. Okay? So here's our periodic table. So how is it organized? So you have periods and groups. Your periods are going to go across. So let's see. This would be a period. Your groups are going to go up and down. So this is a group. And then why are the protons important? Well, if you look at all these numbers, and they're kind of little, but for example, we'll look at beryllium here. So we see that 4. The 4 is actually the number of protons. So the atomic number, which is also how they're arranged. So if you look, there's number 4. Down here is number 118. So the smaller the number of protons. We'll do a little plus. So how to read info on the periodic table. I hope this is also a review for you a little bit. But the atomic number, like we just said, is the number of protons. Those are the positively charged particles in the nucleus of an element. In a neutral element, your atomic number is also your electrons. So let's say silver is neutral. So it has 47 protons and 47 electrons. And if you take chemistry, you'll have to eventually draw these things, where you have to draw the nucleus and fill the outer shells. So what else can we get? So we know the number of protons. So we figured out protons. We figured out electrons. So how do we figure out how many neutrons? So the atomic mass, which is this number at the bottom, it's usually a decimal. Okay, so it's always going to look a little different than the atomic number. So the atomic mass then is the number of protons and neutrons, so added together in an element. So then how do you find the neutrons? You take the atomic mass, so let's see, we'll just abbreviate AM, minus atomic number equals the neutrons. So in the case of this one here, 4.003, and we round when we figure out those things, but round, so this is for now. So we get around 2 neutrons. So that's how many neutrons it has. Now, 2 is also the number of protons and electrons. That will not always be the case. In some elements, you will have a different number of neutrons than your protons or electrons. Alright, so molecules versus compounds. So molecules are atoms then held together by covalent bonds, which is what we've already talked about. Compounds, on the other hand, are 2 or more different elements, and they can only be broken apart by a chemical reaction. Okay, so things like an ice cube melting is a physical reaction, but a chemical reaction is something that's going to require heat or another form of energy added to break apart these bonds. So how do we determine what elements are in a compound? So let's look at this one. We're given HBr. Hopefully you guys all know that H is hydrogen. And Br is bromine. Okay? So we have hydrogen and bromine. So now I want to know how many of each element there are. Well, if we look back at up here, we don't see any numbers, right? So there's 1 hydrogen and 1 bromine. Okay? Let's try another one. So now, how many elements are in this one? So we see H, which we know is hydrogen, and O, which hopefully you also know is oxygen. So we know that we have hydrogen and oxygen. So how many of each element? Now we see a number. So this little number here, that little number there means there's 2 hydrogen. So there's 2 hydrogen and there's only 1 oxygen. So that one's pretty easy. Oh, we'll redraw this. Okay. The second one here is going to be a little bit different because we have this 7 in the front. So the 7, we're kind of back to multiplying, but let's do what they are first. So Fe is iron, and O we know is oxygen. Okay, so how many of each element? Well, we see the 2 and the 3. So we can say, okay, well, there's at least 2 iron and at least 3 oxygen, but that's not totally right. It's going to be 7 times the 2. So 7 times 2 is 14. So we have 14 iron. And then 7 times 3 is 21. So we have 21 oxygen. Imagine that, let's do it in a different color. Imagine that there's a parenthesis here. So it's 7 times the parenthesis. Okay, so your order of operations, which hopefully is not something new to you. And that is it for this set of notes.